So today in this session we are going to learn about the basics of the remote sensing. So the word remote sensing is basically made up of two words, remote and sensing. So remote means distance or distant object, or we can say to analyze the distance. Or sensing means to sense something. That means to getting an idea about any information, getting an idea about the information. Secondly, if you are trying to find some input like the temperature, pressure, humidity of that an area, so this is the meaning of the sensing, to get the information. And from that information, if some user try to find that information useful, then that information becomes the data. So this is the whole knowledge, or we can say the information. And if some user try to find this much of the information useful, then this much of that circle will become data for that person. So this will be the data. So an information only becomes the data if that information is useful for that person. So this is the meaning of data. So whenever we talk about the remote sensing, people understand only about the earth, and this is the satellite, and from this satellite the rays are coming if it is an active satellite, or if it is a passive satellite and it becomes some source of illumination. So this is not actually the real meaning of the satellite, that we only analyze about or will only talk about the earth and the satellite. So what is the actual meaning, or what is the real understanding of the remote sensing? Suppose if we are doing the sonograph. So sonograph is also trying to analyze or to sense the things from the distance object. Secondly, if we are going to understand about the medical imaging, if we are talking about the x-rays, so this all the things are the process of the remote sensing only. It is not only talking about the satellites or the communication processes, but it also contains the idea about if anything that is from you, the distance from you, that is having the distance from you, and you are trying to analyze that things from distance place, then that process is also known as the remote sensing. And in the literal meaning of the remote sensing, which is given first time by the Pruitt, Evely L. Pruitt in 1950s. So she gave the official and the literal definition of the remote sensing as it is the method of measurement, a process. So it is the method of measurement. Mark or highlight this word measurement. Second, from this measurement we are going to acquisition, or we are trying to get a process of information, or trying to find the acquisition of information. acquisition of information, of properties or characteristics, properties or characteristics of any object from distance. So according to the definition that is given by the Elvin L. Pruitt in 1950s, the official definition of the remote sensing does not have any mentioning of the satellite. So it is not mandatory to always the remember about the presence of the satellite while studying the concept of the remote sensing. So let us understand what is the definition of the remote sensing. So definition of remote sensing. So remote sensing is basically the method of measurement, measurement, a process, a process of information, of some property, some property of any object, any object or phenomenon, phenomenon by a recording device, by a recording device that is not in physical or intimate contact with the object under study. So according to the definition, it is the method of measurement a process. So we are measuring a process. So what is the process? In this process, the property of any object is recorded by a instrument or an object, and that object must not be in physical contact or must not be in intimate contact with the object under study. So this is the official definition of the remote sensing, and in this definition there is no mentioning of the satellite. Secondly, when we talking about the remote sensing, so basically we have to understand that every object can be two type. Either it will be the luminous object, either it will be the luminous object, or it can be the non-luminous object. So if the object is luminous, then it has its own light, own light. And if the object is non-luminous, it is dependent upon the any other source. So it has not its own light. So if the object had its own light, so it can be categorized into the active sensor. So if a satellite is equipped with the active sensor, then it need not have any dependence upon the sun or any source of the illumination. But if the object is non-luminous, and if the satellite is non-luminous, or we can say the passive, so it will depend upon a source that has the light, and the light will fall upon that object, and object will record that the substance under the study. So basically, when we are talking about the remote sensing, when we are talking about the remote sensing, this remote sensing, like suppose if someone is doing the video recording, someone is doing the video recording. So what is happening during the video recording? Suppose this is the this DSLR camera, and here is some person. So this camera is recording that person. So first of all there will be a some source of the illumination. So suppose this is the sun, and the radiation is falling upon that person in the daytime. So after, when the radiation will fall upon that person, the radiation will move towards the lens of the camera, and then camera will can easily record or detect that object. So if this process is happening, then it is a passive kind of recording. Why I'm saying this passive word? Because this camera needs the presence of the sun to illuminate this person in order to get that video recording. Where, so let us consider one more example. Suppose this is the night time, so there is no presence of any uh, source of illumination. So under that condition, if this camera has the flashlight, and then the same person is here, and by illuminating this flashlight, the flashlight will fall upon that object, and after the reflection it will reach upon the lens of the camera, that can be either concave lens or the convex lens, depending upon the features of that camera. But since in most of the time, mainly any camera have the convex lens. So suppose through this flash the light will fall upon that person, and after the reflection from that person it will fall upon the convex lens of that camera, and because of this it can get the image of that person. So in this condition we can say that the process is active, or that this object has its own light, so it is luminous and active sensors. So simply, video recording can also be a process of the remote sensing. It is not like that only the satellite can analyze the data on the earth and take the pictures. It is not like that. So nowadays drone cameras. So this drone camera is flying upon some altitude, and here is the object. So from this source of the sun, suppose this insolation will fall upon that camera, no sorry, that insolation will fall upon that person, and after the reflection from that person, the drone can analyze that here the person is standing or take the pictures or video of that person. So here there is the presence of sun. So this drone is dependent upon the sun in while getting the illumination in order to get the video. So if this, suppose this drone has the infrared camera, so it can, it is not necessary to depend this infrared camera upon the sun. It can even in the night time can record this person easily through its sensor, or whether it is a radar equipped drone. So anything can happen in this process. So basically when we are talking about the lenses of the camera, let us understand some basic things. Like there are two type of lenses. The first is the concave lens, concave lens, and second one is the convex lens, convex lens. So the concave lens is that type of the lens which is thinner, which is thinner in the medium and thicker at the edges. You can see the edge is more broader here in the case of the concave lens, while if we are talking about the convex lens, so this convex lens is thicker at the medium, thicker at the medium and thinner at the edges, thicker at the medium and thinner at the edges. So let us consider some example why we are talking about this, because the camera lens is either made up of the convex lens or the concave lens. So suppose this is the concave lens. Here is the principal axis, this is the optical center, and through the optical center any line can pass normally through this, any line can pass normally through this optical center. So let me erase this. So through this optical center any ray can fall normally through this. So suppose if a ray is going parallel to the principal axis, and if this is a concave lens, then the ray will be deflected in this direction, and appears to fall upon the focus, so this is the focus. So here the image that is forming is appears to converge from or appears to fall from this focus. So this is a virtual image, and suppose this is the convex lens. So this is the optical center. So any ray that going parallel to the principal axis will really meet at the focus, So if the ray really meet at the focus, then this is the real image, and this real image is basically inverted, and this virtual image is erect. So in the photographic camera, we actually need the real image on the screen. So in order to get the real image, the camera is mainly of the convex lenses. So suppose if we have the DSLR camera, then this is the convex lens, and we can also insert some external lenses that can be either of the convex or concave, depending upon the power of the lens. That is, the power of the lens is the reciprocal of its focal length. So if you increase the power, the focal length will be decreased, and if you decrease the power, the focal length will be increased. So there is the reciprocal or the inverse relationship between the power of the lens and the focal length. So power of the lens is basically the inverse of its focal length. So our eye is also made up of the convex lens. So suppose if this is our eye, this is our eye, and suppose this is the retina, and a ray going parallel to the principal axis, so a ray going parallel to the principal axis will fall upon this focus. So here the image is forming before the retina. So in this condition, our eye is myopic eye, myopic eye, myopic eye. That means you can see the near object because this focus is before the retina, and image can only be formed in our eye, or we can see any object only when the image must have to fall upon the retina. So in this condition, we put a concave lens in order to correct the myopic eye. We put a concave lens, and when we add this concave lens, the ray will fall upon that retina, and it will be corrected. It will be corrected. Similarly, if the suppose if we have the eye, and this is the principal axis, and in this condition, suppose this is the cornea, retina. This is the retina. So this is retina, or ciliary muscles are basically this retina is made up of cone type and rod type of cells. So if any of them is unable for the working, so it will leads to the eye blindness or the causing a black spot. So suppose our eye, suppose this is our eye lens, which is the convex lens, and ray is going parallel to the principal axis. So in this condition, the ray, in this condition, the object after going parallel to the principal axis will fall beyond this. I mean to say, this is retina. Retina. This is retina. So here you can say the focus is beyond the retina. So in order to correct this, we are using the concave, one more concave lens, and it will lead to increase in the power. So it will after adding this convex lens, the image will form upon the retina. So this is the hypermetropia, or also known as the long sightedness. So in this condition, you are not able to see the near object, but distance object you can see, because you can see this is the retina and focus is here. So beyond the retina the focus is, so you can easily see the distance object. So in order to correct this, we have put one more the convex lens, so that it image can fall upon this retina in order to correct this. One more condition of the disease in our eye, that is the presbyopia. So in this condition, neither we can see the near object or neither we can see the distance object. Presbyopia. So neither we can see the near nor we can see the far. कुछ नहीं देख सकते इसमें. So in that condition, we need a bifocal length. We need a bifocal length. So during this disease, our ciliary muscles will become loose and unable to work. So suppose this is the patient. I am suggesting this spectacles to the patient. So here it has the two concavo-convex lens, that means bifocal length. Here one lens will be of the convex and another will be of concave. One will be of the convex, another will be of the concave. And in one of the most important examination conducted by the UPSC, that is the special class railway apprentice exam, this question has been asked in that this downward part of the presbopic patient, when I am suggesting this spectacles to the patient, so this below lens, this lens will be of the in this lens is made to correct the myopia, that means near, and this lens is inserted in these spectacles to correct the hypermetropia. Now we are going to study further about the remote sensing. So we have clearly understand about the how the satellite will going to work. So this remote sensing, when we are studying, the video recording is also a process of the remote sensing, as we have discussed earlier, and remote sensing is also done in the other wavelength like the infrared or the thermal infrared. Okay, so it can also be done in the other wavelength like infrared or thermal infrared. So basically nu is equal to 1 upon the lambda. So when you will increase the frequency, the wavelength will be decreased. When you will increase the frequency, the wavelength will be decreased. Like if you are discussing about the mechanical waves like primary waves, secondary waves, love waves, or Rayleigh's wave. So suppose these are the surface wave. So suppose this is the P wave. This will be little bit go high. This is the S, and this is the long. So this is the L and R, that is the surface wave. This is the secondary wave, and this one is the primary wave. So here you can see the frequency are very high in case of the mechanical wave of P and S. So it can cause the less destruction because its wavelength is less, while the love wave has the high wavelength. See, when you are connecting this crest and trough, you see the distance between the crest and trough very high. Here you can see very less distance between the two crust and two trough. So its wavelength is very high in case of the love wave. So it is very dangerous and cause the lot of the destruction when the earthquake happens. So this love wave is more destructive. So if we are talking about this love wave, so it will have the frequency that is low. and wavelength that is high. In case of the primary wave, you can see the frequency is very high and its wavelength is very less. In case of the secondary wave, you can see the frequency is although moderate as compared to the P wave, and wavelength is little bit higher than the primary waves. So these are the basically the seismic waves that are going to study the interiors of the earth. I'm connecting here to analyze more about the structures of the waves. Further, I want to add some more information about the how this uh, process of the remote sensing is working, the mechanism of the remote sensing, how remote sensing works, mechanism of the remote sensing, how remote sensing work. So suppose this is the sun is the primary source of the illumination, or we can say the ultimate source of the illumination on the earth, or we can say the only source of the insolation on the earth, if we are not talking about in sense of the electricity or something. So suppose this is the sun and this is the photosphere. This is the photosphere where all the hydrogen are combined to forming the helium. Fusion is going on, and because of this some heat is emerged out from this surface of the sun, that is the photosphere, and it reaches upon the earth surface. So this is the earth, this is the earth surface. So here the radiation are falling upon the earth, and the earth have the different layers of the atmosphere. So these radiations have to travel the through this atmosphere while reaching upon the earth, and some will we have to follow the scattering, that is the Tyndall effect, or we can say the particle that during the reaching on the surface of the earth will scatter because of the suspended particle or the aerosols have to follow the diffusion process. Some will be reflected by the clouds and other phenomena, and the rest remaining insolation which reach upon the surface of the earth. And when it reach upon the surface of the earth, after such the phenomena happening during the process of emission, so when it reach upon the surface of the earth, so here there is the interaction. This word is very important, interaction. So what is the meaning of that interaction? After reaching the surface of the earth by following the different reflection, refraction, diffraction, total internal reflection process, here the interaction of the insolation, or we can say the electromagnetic radiation of the cell falls upon the surface, and after colliding with the surface of the earth, some radiation will be absorbed and some will be reflected back. Sun will be reflected back into the space where our satellite is present, where our satellite is going to present. And in this process our satellite will get the image of that surface after the reflecting the earth surface. So this is the first step of the this is the first step this is the first step of the mechanism of the remote sensing. Now we are talking about the now we are going into the second step of the remote sensing. Second step of the remote sensing. So while dealing with the second step of the remote sensing, now that data of the surface of the earth is recorded by the satellite, and after receiving that data with a satellite, the satellite will transmit this the satellite will transmit this signal on the earth station earth station earth station. It will reach upon the earth station, or we can also say it is a processing center. So what is the meaning of that processing center? This is a very technical and very deep understanding of the word processing center. Here we process the signal that is uh, got through the satellite. So here we can see, or we can, in this station we can correct, we can do the correction of the signal, or we can set some algorithm to finalize some image or data, or do some mathematical codings like AI and machine learning through some, and we try to get the pictures, or the try to produce some data. And when this data is processed, and after processing this data through this processing center, and now this processing center can also be of the government agency, or can also of the private agency like the SpaceX and something. And after this data is now made public for the users. Now who can be the users of that data? So they are the ultimate uh, people who rely upon the data that is processed or given to these users, like the geologist, like the geologist. So if some geologists want to study the structures and the compositions of the rock in the present scenario, and during the 30 to 40 years back, what is the structure and the in, intrinsic characteristic in the rock, if I'm trying to distinguish between the um rock structure from current time zone to the previous time zone, so this data is very useful to analyze and to make some research accordingly. Suppose if some agriculture scientist want to find the history of the disease on a particular region, or trying to find in the plants, suppose the here the plant condition are having lot of the arsenic content and very harmful for the human, it will leads to the cancer. So some agriculture scientists want to study that why this region has all the crops have more amount of the arsenic content. So in that condition also the data is useful, that is given by this processing unit. Now sometimes during the transmission of the signal, suppose this is the receiver, this is the sender, and this is the receiver, and here is the noise, here is our satellite, this is our satellite. Now the signal or the voice input is first of all transmitted. Suppose this is the sun, and through this sun there is the illumination. If that satellite is not the uh, have the active sensors or radio waves or satellite equipped with the radars, then it will have to depend upon this sun radiation, and from this sender the signal is reflected back to the satellite, and there is transducers are fixed here. These transducers will convert the voice signal or any kind of the video signal into the electrical impulse or into the electromagnetic waves, and through these electromagnetic waves it will reach upon the satellite, and after reaching the satellite the data will be sent to the processing unit or to the receivers. So while during this process, sometimes there is so much of the frequencies, or we can say the noise, that disturb our the bandwidth or the frequency of the sender's signal. So in that condition, we do the modulation. We do the modulation or demodulation of the signal, that is sent through the sender. So what is the meaning of the modulation? So sometimes the transmitting signal, that is the sinusoidal wave or in any kind of the signal it can be, that signal is reaching while it is transmitting to the receiver. Sometimes there is so much different frequency that is colliding or disturbing our main signal. So in that condition we further create a signal of the same frequency or the wavelength. This is the displacement of the wave, this is the amplitude, the maximum height attained by a wave is the amplitude. So we superimpose the same wave to our the transmitting wave, and after the superimposition of the transmitting signal, this wave that I am trying to superimpose on that my transmitting signal, that is of the same frequency or the wave bandwidth, will give this inner transfer the energy from our transmitting signal, and our transmitting signal will be stronger, and after this it can easily reach upon the receiver. So this is the process of modulation. Modulation means to improve or to superimpose our transmitting signal by some other signal, and that other signal will give its energy to our transmitting signal, and it will reach to the destination properly and we can get the clear data. Similarly, we also do the demodulation to our signal also while during the transmission. If there is some other kind of the frequency or signals collide with our electromagnetic signals, then we can also remove that useless signals and can improve our main signal. So this is the process of the modulation and demodulation by the receiver and the sender. Now the data that is received by this receiver or through the processing center, we can say this receiver or the data that is received can also be utilized by our geographers also. Like if I'm trying to study about the town planning, so in the 2023 what is the area and how much trees are grown earlier and now what is the current situation in this region, so it can also be helpful in that situation also. Now during the transmission we are going to study some more about the process that are going to be very helpful, that where should our satellite must be uh, put in the orbit, or we can say the geostationary orbit. So suppose this is the sun. This is the sun. This is our sun, and this is the this is the solar corona. This is the solar corona, or we can also say this as de facto atmosphere of the sun, or the photosphere, or also called the solar corona. So from we can already know that our earth is itself a very big magnet. So here this is the north and this will be the south. So the signal will, all the magnetic field will move from this to this, from this to this. Now sometimes what happen, because of the solar wind, our earth magnetic field will protect us from the solar wind. There are a lot of the high intensity of charged particles that are going to collide with our earth magnetic field, and after the collision the magnetic will be dragged to the backward direction. Now after the collision with the solar flares that is made of very charged particles, it is shifted to the backward direction, and it will meet at some point. After meeting that point, some charged particle will will dragged back and collected at the poles of the earth, and collected at the poles of the earth. And this is why we are seeing the polar lights. So this charged particle when collected at the northern hemisphere, so we call this charged particle accumulation as the aurora borealis. Why we are saying this aurora borealis? Because here the tundra type of climate is there, so boreal forest are present in that condition. And similarly, this is known as the aurora australis. Now from this we have this earth. The earth has this magnetic field, and after striking with that solar flare, it will fall to this, and some charged particle will collect at that point, and some charged particle is also trapped in the magnetic field of the earth. Here the charged particle is collected and making the two crescent. This is the inner crescent, and that one is the outer crescent, and these are very much of the high intensively charged particle that can do the combustion of any subject whatever will go through this. So this is the inner crescent is sometimes falling upon the South America region. So it is at the height of this inner crescent is at the height of the 640 kilometer, and that outer crescent is at the height of the 56,000 kilometer. And this inner crescent now dragged or shifted to the South America region and reaches up to the height of 200 kilometer. When it reaches is up to the height of the 200 kilometer, the the magnetic field of that region of the South America become very very weak. So any aircraft or any drones or any the commercial jet streams, jet crafts are avoided to pass through that region, because this region has the very low, or we can say near up to the zero, the magnetic field. This is also known as the South Atlantic anomaly. So why I am discussing this topic? Because whenever we put our satellite in our geostationary orbit is up to the height of the 3,600 36,000 kilometer. So why this is 36,000 kilometer? Because if we are going to put this put our satellite in the Van Allen belt, that is also known as the Van Allen radiation zone, our satellite will destroy. So this is the reason why the geostationary orbit is 36,000 kilometer, because that is the region between the inner crescent of Van Allen radiation zone and the outer crescent of the Van Allen radiation zone. So any spacecraft, any rocket avoid to travel through this Van Allen radiation zone, and our geostationary height is of the satellite height is 36,000, which is between the Van Allen radiation zone of the inner and the outer crescent. So this is why I am going so much deep inside this, to understand exactly all the concept that cause some of the confusions in this topic. Now, when the light signal is transmitting or reaching up to the Earth's surface, the light surface has to travel through the different type of the scattering. That is the relay scattering, or through the Maya scattering, or through the Raman scattering, or we can also say that Raman scattering, that Raman scattering, or the it is also known as the Compton effect. Compton effect. So what is the actual meaning of that Compton effect? So suppose, let us come in the field of the optics. So light has basically the dual characteristics. The first characteristics is of the wave, and the second characteristics is of the particle. So whenever we are talking about the refraction, total internal reflection, scattering, diffraction, diffusion, polarization, this all the phenomena are explaining that the light has the wave characteristics, but at the same time the light has also the particle characteristics. Like whenever we are talking about the photoelectric effect. So suppose this is the PN junction diode, and we are connecting this through a battery, and whenever the sun radiation fall upon this, the diode that is made of the atoms, and from this atom the electron is moving around the outermost orbit, and whenever this photon particle of the light is colliding with this electron, the electron the photon will collide with the electron that is moving on the outermost orbit of the atom. The electron will get the energy from the photon and it will leave its orbit, and whenever there is the free charge carriers or electron will move freely, it will lead to the generation of the electricity. So so the h nu is the photonic energy, and h nu naught is the energy that is given by the photon to electron escape the to escape the half m v square, to escape the orbit of the atom. So this is how the photoelectric effect is going to work. So whenever we talk about the photoelectric effect or the quantum effect, these all effect are explaining about that the light has the particle characteristics as well. So this is all about the optics. Now we are going to understand about the relay scattering. We are going to understand about the relay scattering. So suppose this is our sun. Our sun, it is exactly the red, and radiation or electromagnetic radiation are falling upon the surface of the earth. So if the surface of the earth is flat, if the surface of the earth is flat, so the incident radiation will fall and it will reflect. This is the normal angle of incidence is angle of reflection. Or if you put the sunlight here, then it will also become the incident and it will also become the reflected, and angle of incidence is always equal to angle of refraction. So here all the, since the surface is very smooth or it is of the made up of the mirror, so it is will cause the 100% albedo or the reflection, and no any absorption is can be happened. But when we have the irregular surface, suppose this is the sun and we have the irregular surface. Now if the insulation or the electromagnetic radiation fall upon that surface, it will when it reaches to the surface, some light is absorbed by the surface and it will lead to the scattering. It will lead to the scattering in the many direction. Scattering will happen even we have the irregular surface. So the rough surface may be deflected in all direction with the loss of coherence and phase. So this radiation is basically following in a sine wave. It can be sinusoidal radiation also. So suppose this is the 0, this is pi by 2, that is 90, 9180, this is 270, this is 360. Now from if sine 90 degrees is equal to 1, if put for the highest amplitude, sine 180 degree is equal to 0, sine 270 degree is the minus 1, and sine 2 pi, that is the 360 degree, is further 0. So this is all the displacement of the wave, and displacement of the wave can be given by x is equal to a sine omega t plus minus phi. Here phi is the phase difference, omega is the 2 pi by t. So we can write this a is equal to a sine omega 2 pi by t into t plus minus phi. This is the displacement of the sinusoidal wave or the electromagnetic radiation. So why omega is 2 pi? Since suppose from 0 to the 180 it will reach here, and from 180 to 360 it will reach up to the here, the whole circle we have 2 pi, and we cover this 2 pi in the t time, so 2 pi by t. So omega is equal to the 2 pi by t. Now the rough surface may be deflected in all directions with the loss of the coherence and phase. So it will depend upon the degree of the scattering, or depend upon the size of the particle, and also depend upon the wavelength. So it will depend upon the size of particle or depend upon the wavelength. Suppose we have the nanoparticle or very minute particle here. So um, suppose this radiation is have very less frequency, sorry, very high frequency. See, this has very high frequency. So the probability of interaction with this minute nanoparticle, that is 10 to the power में minus 3 is milli, minus 6 is micro, milli, micro, nano, 6 7 हाँ 9, this is the nano, this is the nano. In our engineering college I have studied about this functions of the nano, that is the through the top down process or bottom up approach process. So here we are discussing this minute aerosol particle that is also in as small as that of the nanoparticle. So here the blue light, that is the that frequency is very high. So if that frequency is very high, that blue light has the least wavelength and frequency. Since frequency is very high, so it has the more of the uh, penetrating power, or so it will in so it, so the probability of interaction with this nano minute particle of the aerosol will become higher. So here it will interact with this minute particle, and here the scattering will happen in all direction. And here we can see this blue light scattering we are seeing, because that blue light has the least wavelength and highest frequency, or the shorter wave. So if this is shorter wave or frequency is very high and the wavelength is very less, so its probability of interaction with that minute particle will become very high and do the scattering and produces that white light, sorry, blue light. And that blue light is, we are seeing, that is absorbed by this relay, and so this is also known as the relay scattering. So relay is equal to elastic minus 1 by lambda to the power में minus 4. So if you will decrease the lambda, that is the wavelength, your relay frequency or scattering of this blue light will be more. Where if you increase this lambda, your relay scattering or the scattering of that blue light will be less. So this is known as the actual meaning of the relay scattering. So this is our suppose this is our sun. So suppose this is our sun, and from the sun, so this is the green light, this is the red light, and this is the blue light, and here we can see this white light, this is the white light. So suppose this green and red has the high wavelength, and here we can see this blue light has the shorter wavelength. Now we have this particle, aerosol particle. So this, because this have the higher wavelength, so this interaction, the probability of getting interaction with that minute particle will be very less. So this blue light, because of this high frequency and shorter wavelength, it interaction is probability of getting interaction with that minute particle will be very high. So what will happen, it will scattered in all direction, and the person here absorbing this process will say the sky appears blue. So here the sky appears blue because of the relay scattering. I hope you will understand. Now we are understanding about the my scattering. So the in case of the my scattering, so in case of the my scattering, in case of the my scattering, in case of the my scattering, we have the a small particle. So we are not getting the particle as small as of the nanoparticle, as we have already studied in the relay. So this is little bit larger particle, a small particle, and this is the large particle, large particle. So this particle, if suppose this is the sun, this is the again green, this is again red, this is again red, and this is again blue. Here you can set this white. So suppose this is the cloud, this is the atmosphere, and we are getting some moderate and some big particles of also nanoparticle. So here what will happen? Suppose in this my scattering we see the clouds at white in color. So why this during the my scattering we see the clouds having the white in color? Because when the red light or the green light have the high wavelength, then that particle size or the diameter of that particle must be equal or greater than that of the wavelength of that incident radiation. So if it will not have the size big or equal to that of the wavelength, the wavelength will not pass through that particle, and under that condition the scattering will not happen. So in order to do the interaction, that diameter must be greater than or equal to that of the wavelength of the electromagnetic radiation. So here after so here this is the blue also. So after some time in the Maya scattering, after interaction with this small particle or large particle, we are after the reflection or scattering from this particle, the blue light, green light, and red light will meet at that point. And when this blue light, red light, and this green light is made, it will make the white light. So in the case of the my scattering, we are getting the white light. We are getting the white light. Now let us make a principle. So from this whole phenomena we can create a principle or some characteristics. Some characteristics we can make, like change in the, we can say, change in the size of nano particles, or we can say the aerosols or suspended particle in the atmosphere. Suspended particles in atmosphere, the optical characteristics of the incident radiation or the matter changes. Optical characteristics will be changed. So whenever you do the changing in the in the shape of the suspended particle, the different kind of the scattering you can get. Like here in the case of the relay scattering, we see the particles are as small as that of the nanoparticle, but here in the my scattering you will see the small particle and the large particle as well, whose diameter are equal or greater than that of the incident lambda of the electromagnetic radiation. So here the my scattering happens only, my scattering scattering occurs when the diameter of the atmospheric particle are similar or larger than the wavelength of the electromagnetic radiation, that is the light is also an electromagnetic radiation, so it is traveling in the space. Now let us make some difference between the let us make some difference between the let us make some difference between the relay scattering and the Raman scattering. Make some point that is very fruitful. It can come in the examinations of any competition. So here in the case of the relay scattering, the energy of particle is conserved. Here the energy of the particle is conserved. Here not conserved. Second, here you can see the scattering. Here you can see the inelastic scattering. Third, here no change in lambda or frequency. Here you can see the change in the lambda or frequency, that is lambda or nu. Here no change in chemical nature. Here you can see the change in the because here you are treating the light as a particle I have already discussed, that is the photon. So here the change in the chemical nature, or here the size, that is the A size, is very small to that of the lambda of the incident electromagnetic radiation, and here the A size is greater than that of the lambda, or